Cleveland, Ohio, October 1962. Inside a converted factory on the city's east side, the overhead cranes hang still. Weeks earlier, they were lifting 16-cylinder diesel blocks the size of delivery trucks, engines built to survive 400 feet underwater, under enemy fire, in total darkness. Now a foreman walks the floor with a clipboard, crossing out serial numbers on machines that will never be finished. No explosion, no headline, no press conference. Just paperwork, and the particular silence of a factory being told to stop. 20 years earlier, this same floor ran 3 shifts a day, 7 days a week. It built the engine that saved American submarine crews after a different engine, a faster, cheaper, rushed engine, had already started killing them. General Motors didn't just build a diesel here. It built the machine the U.S. Navy trusted with its sailors' lives in the deadliest years of the Pacific War. That engine won. It never let a crew down. And less than 2 decades after the war ended, the company that built it walked away, so quietly that almost nobody noticed, and almost nobody remembers the name today. But the real story of GM's Cleveland diesel engine division is not just about a factory that closed. It is the story of what happens to the engine that wins the war, and what happened when the U.S. Navy stopped needing it at all. Every week on this channel, we take apart the names and machines that once defined American industrial power. The engines, factories, and brands that carried the country through war and prosperity, and then disappeared so quietly, most people never noticed. This is the story of what happens when the market that made you finally moves on. If stories about the machines America forgot are the kind of thing you want more of, consider subscribing. Now, back to Cleveland. The story begins not with nostalgia, but with a specific place in Cleveland, Ohio, in 1930. That year, General Motors, already the largest industrial corporation in the country, bought a struggling engine maker most Americans had never heard of. The company was small. Its founder was not. Alexander Winton had spent 3 decades chasing horsepower. In 1897, he built one of the first gasoline automobiles sold commercially in the United States, years before Henry Ford put a car on a National Assembly line. Winton raced his own cars, set early speed records, and by some accounts turned down the chance to sell his automobile patents to a young inventor named Ford, a decision that, in hindsight, cost him a place in history he might otherwise have owned outright. But Winton's real obsession was never the car. It was the engine underneath it. By the early 1910s, Winton had shifted away from automobiles entirely and founded a new venture, an engine company building diesels for boats, for industrial power plants, for anything that needed torque without the smell and noise of gasoline. This is the pivot that mattered. The man who might be remembered as an automobile pioneer chose instead to spend the second half of his career building the unglamorous oil-black heart of American industry, compression ignition engines nobody outside a machine shop would ever see. That decision put Winton Engine Company in exactly the right place. When Detroit's largest automaker came looking for diesel expertise in 1930, General Motors was expanding aggressively into diesel power, for locomotives, for marine use, for the industrial backbone of a country still climbing out of economic uncertainty. Winton's small Cleveland operation, with its decades of engine-building know-how, was absorbed into the General Motors empire almost overnight. For 8 years, Winton's diesel technology lived inside GM as a single unit, serving 2 very different markets at once, railroads on one side, marine and stationary power on the other. But those markets didn't behave the same way, and by 1938 General Motors made the decision to split the business in 2. One half became the Electromotive Division, based in LaGrange, Illinois, the operation that would go on to reshape American railroading with diesel locomotives. A story for another day. The other half stayed in Cleveland, kept the Winton engineering talent, and took on a new name, the Cleveland Diesel Engine Division. This is the company's true birthplace. Not a garage, not a single inventor's workshop, but a corporate restructuring inside the largest industrial company on earth. There was no single founder standing at the door in 1938. There was an engineering culture, inherited from a man who'd already reinvented himself once, now being pointed at a new and far more demanding customer, the United States Navy. The unmet need was simple to state and brutally hard to solve. Submarines needed diesel engines that could run for weeks without failure, in engine rooms with no room for a technician to improvise, hundreds of miles from the nearest repair yard. A diesel engine on a truck could break down on the side of a road. A diesel engine on a submarine broke down at the bottom of the ocean, usually with enemy destroyers listening for exactly that kind of trouble. Reliability wasn't a selling point. It was the entire product. In the late 1930s, as war clouds gathered over Europe and the Pacific, the U.S. Navy was quietly searching for diesel suppliers who could meet that standard at scale. Cleveland Diesel Engine Division didn't have a flagship product yet. It didn't have a signature engine with a name that every submariner would come to trust. What it had was Winton's engineering lineage, GM's manufacturing muscle, and a location in Cleveland, Ohio, close to the industrial supply chains that would soon be feeding the largest wartime shipbuilding effort in American history. Nobody in Cleveland in 1938 could have predicted how urgently the Navy would need them within 4 years. Nobody could have known that another engine, built by another company entirely, was about to fail so badly, so publicly, and so dangerously that Cleveland Diesel would be handed the job of saving American submarine crews from their own machinery. That failure is where the real story begins. To understand why Cleveland Diesel mattered, you first have to understand the engine it was built to replace. In the early years of American submarine construction, the Navy needed a lightweight, high-output diesel engine that could fit inside a hull barely wider than a city bus. The contract went to a company called Hooven, Owens, Rentschler, a Hamilton, Ohio manufacturer that built its engine under license from a German design. On paper, it looked promising, compact, powerful, engineered by people who understood diesel technology at a theoretical level few American firms could match. In practice, it was a disaster. The HOR engine relied on a flexible drive coupling, a mechanical joint designed to absorb the engine's vibration before it reached the submarine's propeller shaft. Under sustained operation, that coupling failed. Gears stripped, crankshafts cracked. Submarines limped home on one engine instead of 4, or sat dead in the water in contested territory, while their crews prayed no enemy patrol boat happened by. This was happening in 1942 and 1943, the worst possible years for American submarines to have unreliable engines, because American submarines were, at that exact moment, the only weapon consistently sinking Japanese shipping in the Pacific. A diesel engine, in the simplest terms, is a piston engine that ignites its fuel through compression alone. No spark plug, just air squeezed hard enough inside a cylinder to generate the heat needed for combustion. It's a design prize for torque and fuel efficiency, which is why it dominates ships, trucks, and submarines to this day. The HOR engine was a diesel in every technical sense. What it lacked was durability under the specific brutal conditions of underwater warfare. Thousands of hours of continuous running, extreme temperature swings, and zero tolerance for failure. The Navy needed a fix, and it needed one immediately. That fix came from 2 directions at once. Fairbanks Morse, an established Wisconsin manufacturer already supplying diesels to the Navy, and General Motors' Cleveland Diesel Engine Division, the newly renamed Winton operation that just a few years earlier had been an internal corporate afterthought. Cleveland Diesel's answer was a family of engines built around a V-type configuration, meaning the cylinders were arranged in 2 angled banks meeting at a shared crankshaft, rather than lined up in a single row. A V-type engine packs more cylinders, and therefore more power, into a shorter overall length. A critical advantage inside a submarine hull, where every foot of engine room space competed directly with torpedo storage, battery banks, and crew quarters. The engine that emerged from this effort was the GM 16278A, 16 cylinders arranged in a V, producing in the range of 1,600 horsepower per unit, with submarines typically carrying 4 of them to power both propulsion and battery charging simultaneously. Displacement, weight, and output figures varied across production runs and later revisions. and exact wartime specifications are still debated among naval historians today. But the US engine's reputation was never in doubt among the men who ran it. Where the HOR engine had relied on a failure-prone flexible coupling, the Cleveland diesel design used a more robust mechanical arrangement that distributed vibration and load differently across the crankshaft assembly. A difference that sounds minor on an engineering drawing and meant everything 200 feet underwater. The engine simply didn't quit. It ran through depth charge attacks, through weeks of continuous patrol, through the kind of punishing operational tempo that had exposed every weakness in its predecessor within months. Fairbanks-Morse, for its part, had taken a completely different engineering approach, an opposed piston design, where two pistons shared a single cylinder and moved toward each other rather than against a fixed cylinder head. It was a legitimate competing philosophy for solving the bunging problem, and by the middle of the war, the U.S. Navy was running both engines in parallel across its submarine fleet, refusing to bet the entire force on a single manufacturer ever again. That decision, a direct lesson learned from the HOR catastrophe, would define submarine engine procurement for the next 2 decades. The first real proof of Cleveland Diesel's engine came not in a laboratory, but in the Pacific itself, as HOR-powered submarines were pulled in for engine replacements, and newer boats rolled off the line with Cleveland diesel power plants installed from the keel up. Submarines like USS Ho and USS Pompano, vessels that had experienced firsthand what an unreliable engine cost a crew in fear and lost patrol time, went on to complete war patrols powered by the new engines, without the catastrophic mechanical failures that had plagued the fleet a year earlier. Cleveland, Ohio, a city known for steel and machine tools, had quietly built the engine that let American submarines do their job without their own machinery being the thing most likely to kill them. The division was no longer an internal GM afterthought. It was now one of 2 companies the United States Navy trusted with the lives of every submarine crew in the Pacific. By 1943, Cleveland Diesel wasn't just fixing a wartime emergency. It was scaling into full production, and the engine family was evolving fast enough that no 2 years of the war looked quite the same on the factory floor. The 16278A remained the flagship, 4 units per submarine, arranged in pairs fore and aft of the control room, each one roughly the size of a delivery truck, and weighing in the range of 8 to 9 tons. But alongside it, Cleveland Diesel produced a smaller sibling, the 8268A, an 8-cylinder version built for auxiliary power, and for vessels that didn't need the full output of the flagship engine. Where the 16278A was the primary propulsion plant, the 8268A often ran the ship's electrical systems and battery charging loads, giving submarine crews redundancy. If one engine family had a problem, the boat wasn't entirely dead in the water. Each new production year brought incremental refinements rather than dramatic redesigns, tighter tolerances on bearing surfaces, improved cooling passages, adjustments to fuel injection timing that squeezed out a little more reliability or a little more horsepower without changing the fundamental architecture that had already proven itself. This was, in its own way, the engine's greatest strength. The Navy didn't want innovation for its own sake in the middle of a 2-ocean war. It wanted the same engine, built the same way, 10,000 times in a row, with just enough refinement to keep it ahead of the punishment submarines were absorbing on every patrol. Fairbanks-Morse, meanwhile, was scaling its own opposed piston design in parallel, and the competitive dynamic between the 2 companies pushed both toward continuous improvement rather than complacency. Neither company could afford to fall behind the other, because the Navy was watching failure rates from both suppliers with the memory of the HOR disaster still fresh. A single embarrassing engine failure, reported up through the Bureau of Ships, could shift future contracts overnight. That pressure, quiet, constant, and existential, kept both engine families improving throughout the war years. The customer base, meanwhile, expanded well beyond the submarines Cleveland Diesel had been built to serve. Fleet submarines of the Gato and Balao classes, the workhorses of the American submarine force, over 120 boats combined, carried Cleveland Diesel or Fairbanks-Morse power plants into every major theater of the Pacific War. Beyond submarines, The division's diesels found their way into auxiliary Navy vessels, landing craft support ships, and industrial applications back home, wherever GM's wartime production apparatus needed a reliable diesel engine at scale. But the number that mattered most wasn't a specification. It was a name, or rather thousands of names. The engineers, machinists, and quality inspectors who turned a promising design into a mass-produced weapon of war. Picture a mid-level engineer at the Cleveland plant in 1944. A man in his 30s, likely exempted from the draft because his skills were considered essential to the war effort, standing over an engine block fresh off the assembly line with a torque wrench and a checklist longer than his forearm. His job wasn't glamorous. It was inspection, checking bearing clearances, verifying fuel injector calibration, signing off on a machine that would, within weeks, be lowered into a submarine hull and sent to depths where his mistake could kill 24 men. Multiply that engineer by the hundreds who staffed the Cleveland plant during a peak wartime production, and you start to understand what reliability actually cost. Not a slogan, but thousands of individual acts of obsessive, unglamorous precision, repeated every single day for years. Submariners who served on Cleveland diesel-powered boats came to trust the engines in a way that bordered on superstition. Sailors talking about their engines, the way infantry talked about a rifle that had never jammed. Crews rotating onto a new boat asked, before anything else, whether it carried Cleveland diesel or Fairbanks Morse power plants. Not because one was dramatically better than the other by 1944, but because both had earned the reputation. The HOR engine never had and never would. The reputation of an engine a man could trust his life to without thinking twice. By the war's final year, the two companies together had effectively become the entire submarine diesel supply chain for the United States Navy, a duopoly born directly out of catastrophe, sustained by wartime demand that seemed, in 1945, like it would never end. Cleveland Diesel had gone from an internal corporate reshuffling in 1938 to one of the two companies the U.S. Navy could not fight the Pacific War without. The division that didn't exist under its own name until 7 years earlier was now inseparable from the story of how America won underwater. Nobody on that factory floor in 1944, torque wrench in hand, could have imagined that the very technology this engine had helped perfect, naval reactors, nuclear propulsion, an idea still confined to theoretical papers and a handful of ambitious officers, would one day make everything they were building obsolete within a single generation. By the late 1940s, Cleveland Diesel wasn't just building engines. It had become infrastructure, the kind of institution so embedded in Navy operations that nobody stopped to ask what would happen if it ever went away. The Navy had built an entire ecosystem around the 16278A and its siblings. Submarine tenders, support ships that traveled with the fleet, carrying spare parts and machine shops out to sea, stocked Cleveland Diesel components as standard inventory, the same way a modern airline stocks parts for a specific aircraft engine across its entire fleet. Naval training schools ran dedicated courses on Cleveland Diesel maintenance, producing a generation of machinists' mates who could strip an engine block down to its crankshaft blindfolded, trained on nothing but this engine family for the entirety of their careers. Certification wasn't informal. A sailor didn't touch a 16278A engine room without qualifying on it specifically, the same way a submarine officer had to qualify separately on diving, on torpedoes, on every discrete system that kept the boat alive. This is what dominance actually looks like in heavy industry. Not a famous brand name, but a supply chain so deeply threaded into daily operations that removing it would require rebuilding half the institution around it. There was a ritual to it too, one repeated on every submarine, in every ocean, on every patrol. Below decks, in the aft engine room, a machinist's mate would run his hand along the crankcase of a running engine, not checking a gauge, just feeling it. The way a mechanic listens to an old truck engine by ear rather than by instrument. The engine had a particular rhythm at cruising speed, a low mechanical heartbeat transmitted through the deck plates into a sailor's boots, felt as much as heard. Veterans of the submarine service, decades later, would describe that vibration as one of the most vivid physical memories of their entire service. The exact pulse of the engine that kept them alive, distinguishable, they claimed, from any other machine afloat. Peak wartime production numbers back up what that ritual suggests. Across the war years, Cleveland Diesel and its Winton-derived engineering lineage produced diesel engines by the thousands, powering the overwhelming majority of the roughly 160 fleet submarines commissioned by the U.S. Navy during World War II. Split between Cleveland Diesel and Fairbanks Morse power plants, by some contemporary estimates, the two companies together accounted for nearly the entire American submarine diesel market, a level of market concentration that in peacetime might have drawn antitrust scrutiny, but in wartime was simply considered prudent redundancy. And when the war ended in August 1945, nothing about Cleveland Diesel's position looked remotely fragile. The Navy still needed submarines. Submarines still needed diesel engines. Nuclear propulsion existed only as a set of theoretical papers circulating among a small group of ambitious officers. One of them, the intense, relatively junior captain named Hyman Rickover. At that point, still years away from having the institutional power to act on his obsession, the post-war Navy, drawing down from its wartime peak but still the largest submarine force on Earth, continued placing orders. Cleveland Diesel continued refining its engines. The service schools continued training sailors on the same equipment they'd trained on since 1943. By the early 1950s, standing on that Cleveland factory floor, watching engine blocks move down the line toward yet another order of Balao and Tench-class boats being refitted or newly commissioned, there was no reasonable version of the future that included this division closing. The engine had won a war. It had a permanent structural role in how the U.S. Navy trained its sailors, supplied its fleet, and thought about underwater propulsion. Fairbanks Morse was a healthy competitor, not an existential threat. GM's corporate leadership had no reason to view Cleveland Diesel as anything but a stable, essential piece of the company's sprawling industrial portfolio. This was the absolute high point, the moment when collapse would have sounded, to anyone standing in that building, like the least likely outcome in American industry. 400 miles away, in a Navy office building, a different kind of engine was about to make all of it irrelevant. But finding the top of the market is dangerous, because that is exactly where the rules begin to change. On January 21, 1954, the submarine USS Nautilus slid into the water at Groton, Connecticut, and Eleanor Roosevelt broke the traditional bottle of champagne across its bow. It looked, from the outside, like any other submarine launch, a familiar ceremony the Navy had performed dozens of times for Cleveland diesel-powered boats over the previous decade. It was nothing of the kind. Nautilus carried no diesel engines at all. Its power came from a nuclear reactor, designed under the relentless, uncompromising direction of that same captain who'd been circulating theoretical papers a decade earlier, now a driven, increasingly powerful figure named Hyman Rickover. A submarine with a nuclear reactor didn't need to surface to recharge batteries. It didn't need air to run its engines. It could, in theory, stay submerged almost indefinitely, moving faster and quieter than any diesel-electric boat the U.S. Navy had ever built. Cleveland Diesel had spent 16 years perfecting an engine that let submarines survive underwater for 8 hours at a time before surfacing became necessary. Nautilus was about to make hours the wrong unit of measurement entirely. Nobody inside the Cleveland Diesel engine division was fired that week. Nobody's contract was canceled. The Navy still needed diesel-electric submarines. Nuclear propulsion was expensive, unproven at scale, and years away from replacing the existing fleet. But something had shifted, quietly and permanently, in the direction the United States Navy was now willing to spend its money and its ambition. The engine that had won the war was no longer racing toward the future. It was starting for the first time to run against the clock. Success traps rarely announce themselves. They look at first like sound business decisions. For nearly a decade after Nautilus, Cleveland Diesel didn't collapse. It adapted, or tried to. The division kept refining its existing engine lines, kept supplying the diesel-electric boats still under construction, and kept training sailors in the same certification programs that had run since the war. On paper, demand hadn't disappeared. The U.S. Navy still operated dozens of diesel-electric submarines throughout the 1950s, and older boats needed replacement engines. spare parts, and overhauls for years to come. Cleveland Diesel wasn't losing money. It was simply no longer where the future of undersea warfare was being written. That was the first compounding pressure, a slow structural redirection of Navy investment. Nuclear propulsion required an entirely different kind of engineering, reactor design, radiation shielding, a level of government oversight and security clearance that had nothing to do with diesel combustion at all. The Navy's shipbuilding budget didn't vanish, but its priorities inverted. Every dollar spent accelerating the nuclear submarine program was, implicitly, a dollar not spent expanding the diesel-electric fleet. Cleveland Diesel found itself competing for a shrinking share of a budget that used to be entirely its own. The second pressure was technical obsolescence dressed up as continuity. Cleveland Diesel's engineering talent, inherited from Winton, refined across 2 decades of wartime and post-war production, was deep, specific, and almost entirely built around compression-ignition combustion. Retraining that workforce for nuclear engineering wasn't a matter of a few seminars. It required different degrees, different security clearances, an entirely different relationship with the Atomic Energy Commission and Rickover's tightly controlled Naval Reactors program, which guarded its technical knowledge with an intensity that bordered on paranoid. GM, as a corporation, could have chosen to build that capability from scratch. It chose not to, a decision that looked, in any given boardroom meeting of the mid-1950s, entirely rational. Diesel engines were still profitable. Nuclear propulsion was an unproven, capital-intensive gamble controlled almost entirely by one uncompromising Navy officer, who had little patience for corporate partners he didn't personally trust. The third pressure came from inside General Motors itself. By the mid-1950s, GM was the largest industrial corporation on Earth, with automotive divisions generating profits that dwarfed anything a specialized military diesel operation could produce. Cleveland Diesel had never been more than a modest contributor to GM's overall balance sheet, even at its wartime peak. Its value to the corporation had always been strategic and reputational, as much as financial, a demonstration of GM's manufacturing versatility during a national emergency that no longer existed. As GM's corporate leadership allocated capital across dozens of divisions in the post-war boom years, a diesel operation serving a shrinking Navy niche was never going to win an internal competition against an automotive or electromotive's thriving locomotive business. None of these pressures, on their own, looked like a crisis. That was precisely the problem. Each individual decision: decline to build nuclear engineering capability, maintain existing diesel production at current levels, allocate corporate capital toward higher margin divisions, was defensible, even prudent, when viewed in isolation. GM wasn't run by people who failed to notice Nautilus. It was run by people who correctly calculated that entering the nuclear submarine business from a diesel engine foundation would be enormously expensive, technically unproven, and controlled by a Navy program that showed little interest in bringing new corporate partners into its inner circle. What none of those calculations fully priced in was the speed of the transition once it began in earnest. Diesel-electric submarine orders didn't disappear overnight in 1954, but by the early 1960s, as the nuclear fleet expanded past its own early growing pains and proved it could be built at increasing scale, the Navy's remaining diesel-electric orders slowed to a trickle. Cleveland Diesel's customer base wasn't eroding gradually anymore. It was approaching zero. Inside the Cleveland plant, production schedules that had run continuously since 1938 began showing gaps for the first time. Weeks with no new submarine engine orders at all, filled instead with overhaul contracts for engines already in service, a business model that had an obvious and finite endpoint. The engineers who'd spent their careers perfecting the 16278A found themselves working on a product line with no clear successor, inside a division whose reason for existing, America's need for diesel-electric submarine power, was being quietly retired boat by boat, faster than anyone at GM had modeled just a few years earlier. The first cracks weren't visible from outside the building. They showed up in a production schedule, in a shrinking backlog of new orders, in a workforce that still showed up every day to build an engine the Navy was buying less and less of. By 1960, The division that had once been inseparable from how America fought underwater was running on inertia, on existing contracts, and on the quiet hope that diesel-electric submarines still had a longer future than the numbers actually suggested. They didn't. The engine still ran. The market disappeared. The factory slowed. The name changed hands. By 1961, General Motors' corporate leadership had seen enough. Internal reviews of the Cleveland diesel engine division showed what the production floor had already been telling anyone paying attention for years. A shrinking order book. A customer. The U.S. Navy, whose submarine construction budget was now overwhelmingly nuclear, and a specialized engineering workforce, increasingly difficult to justify against the division's declining revenue. The math that had once made Cleveland Diesel a point of corporate pride now made it a line item under review. There was no single dramatic failure to point to. No accident. No scandal. No public controversy. That absence of drama is, in its own way, the most revealing detail of the entire collapse. Companies that fail spectacularly get remembered. Companies that fail quietly, through the accumulated weight of a market that simply stopped needing them, tend to disappear from public memory almost as fast as they disappear from the org chart. By some accounts, General Motors made the decision to wind down Cleveland Diesel Engine Division operations in 1962, consolidating what remained of the company's marine and industrial diesel interests into other parts of the corporation rather than maintaining a standalone division built around a submarine engine market that had all but vanished. The exact closure date, the precise mechanics of the wind-down, and the full disposition of the division's remaining contracts are not consistently documented in public GM corporate histories. A reminder that not every ending in American industry gets a press release, let alone an obituary. What is clear is the outcome. The Cleveland Diesel Engine Division, as an independent operating unit within General Motors, ceased to exist. The plant that had built the engines powering the majority of America's submarine fleet, the operation that had trained thousands of Navy machinists' mates, that had solved a crisis the HOR engine created, that had stood at the absolute center of underwater warfare for nearly 2 decades, was folded away inside a corporation so large that the closure barely registered as a rounding error on GM's overall balance sheet. For the people who'd built their careers there, the human cost was neither abstract nor small. Even if it never made national headlines, engineers who had spent 20 years perfecting a single-engine family, men who could diagnose a bearing failure by the sound of a running engine alone, faced a job market with limited demand for that exact expertise. Some transferred within General Motors to other divisions. Others left the diesel industry entirely, taking their specialized knowledge into automotive engineering, industrial manufacturing, or retirement wherever a corporation their age and experience could still find a use for them. The city of Cleveland absorbed a smaller, quieter version of a story that would repeat across American manufacturing for the next several decades. A specialized industrial employer scaling down not because of scandal or incompetence, but because the specific thing it built brilliantly had simply stopped being what the customer needed. Cleveland Diesel wasn't the city's largest employer, and its closure didn't devastate the local economy the way a single industry town collapse might have elsewhere in the country. But for the sailors who'd trained on its engines, and the families who'd built lives around jobs at that plant, it marked the quiet end of an institution that had, for a brief and intense period of American history, been trusted with more human lives than almost any other engine built on American soil. Fairbanks Morse, Cleveland Diesel's old wartime rival and Navy-mandated competitor, absorbed the diesel-electric submarine business that remained. It wasn't much of a fight. There wasn't much of a market left to fight over. The company that had once shared an entire industry with Cleveland Diesel, born out of the same wartime emergency, now stood essentially alone, not because it had outcompeted its rival in any conventional sense, but because it had simply outlasted the era that created them both. By the time the last diesel-electric submarines in active U.S. Navy service were retired, in the years that followed, the engine built to save American submariners from a catastrophic mechanical failure in 1942 had itself become a historical footnote, remembered, if at all, by the aging veterans who'd felt its heartbeat through the deck plates of a submarine. 400 feet under the Pacific, in a war that had needed it more than almost anything else America built. The factory in Cleveland kept standing. The name on the building changed. Nobody wrote its obituary. Today, the Cleveland Diesel Engine Division does not exist. It has not existed, in any operating form, for more than 60 years. What remains of General Motors' marine and industrial diesel interests was absorbed, restructured, and eventually sold off entirely as GM refocused, decade after decade, on its automotive core. A company that once built the engine trusted with more submarine crews than almost any other manufacturer in American history now has no meaningful connection to diesel propulsion of any kind. Fairbanks Morse, by contrast, is still operating. The company that once stood as Cleveland Diesel's wartime equal, sharing the same Navy contracts, training the same kind of certified technicians, solving the same engineering problems from a different mechanical direction, survived the nuclear transition that ended its rival, and continues building marine diesel engines for the U.S. Navy and commercial customers today. It is, in a very real sense, the last man standing from a duopoly forged in the crisis of 1942. Walk through a Fairbanks Morse engine room today, and you're looking at the direct descendant of a rivalry that once decided which submarines came home from patrol. Return for a moment to that Cleveland factory floor from the opening of this story. October 1962. Cranes hanging still. A foreman's clipboard marking off engines that would never be finished. That building didn't vanish either. Industrial buildings rarely do. They simply change hands, change purpose, and lose the specific memory of what they once meant. Somewhere in Cleveland, Ohio, portions of that manufacturing footprint have been repurposed, subdivided, or absorbed into other industrial uses over the following 6 decades. The physical evidence of Cleveland Diesel's existence surviving even as the institutional memory of it faded, almost completely. But the engines themselves didn't all disappear. A handful of preserved World War II fleet submarines, museum ships open to the public today, like USS Silversides in Muskegon, Michigan, and USS Cod in Cleveland's own harbor, still carry their original Cleveland Diesel or Fairbanks Morse power plants, engine rooms preserved in something close to their wartime condition. Visitors who climb down into those engine rooms today can stand exactly where a machinist's mate once ran a hand along a crankcase, feeling for the particular mechanical heartbeat that submariners once swore they could identify blindfolded. Here is the unexpected footnote. Among a small, dedicated community of marine engine historians, retired Navy machinists' mates, and diesel restoration enthusiasts, the Cleveland Diesel Engine Division is not forgotten at all. It's revered in the specific technical way that niche enthusiast communities revere things the broader public has moved past entirely. Online forums dedicated to historic diesel engines still trade documentation, parts diagrams, and first-hand maintenance manuals for the 16278A, more than 80 years after the engine first entered production. Volunteers aboard preserved submarine museum ships train, informally, in the same maintenance procedures Navy sailors learned in the 1940s, keeping engines that haven't built forward propulsion in decades in enough working order to start and run for visitors on special occasions. A mechanical heartbeat, briefly restarted, inside a hull that no longer goes anywhere. There is something fitting in that. Cleveland Diesel was never a consumer brand. It never had a logo people wore on a jacket. Never had the kind of public recognition that automotive divisions or famous engine names accumulate over generations. Its entire reputation was built inside engine rooms, inside submarine hulls, inside a relationship of total trust between a machine and the small number of men whose lives depended on it working exactly as designed, every single time, with no margin for a second chance. That kind of reputation doesn't translate into lasting public fame. It translates into something quieter and, in its own way, more remarkable. An engine so reliable that the people who depended on it most are still, 6 decades later, the only ones who remember its name. The Cleveland Diesel Engine Division was born out of another company's catastrophic failure. Built an engine that helped win a war in the Pacific, stood at the absolute center of American undersea power for nearly 20 years, and then closed so quietly that most of the country never noticed it was gone. It wasn't beaten by a competitor. It wasn't destroyed by scandal or mismanagement. It was simply outrun by a faster, quieter, more capable idea. A nuclear reactor that didn't need to breathe. And there was no version of a diesel engine company, however well built, that could have out-engineered its way around that. Some machines don't fail. They just run out of a future to belong to. Somewhere in a preserved submarine's engine room, a 16-cylinder diesel that once helped win a war still turns over for visitors on special occasions. A heartbeat from an era that ended before most of them were born. See you in the next one.